Let's just leave it there. It's fine.
Okay, so addition polymerization. This polymerization is only for the alkene one. Okay, like you have this one, CC like this, and then CH3, and then a double bond here, and then an H, and an H, and an H right here. See, what do you call it? Is it propene? Right, it's propene.
No, it's. Wait.
We got three
Oh,
C's.
yeah.
1, 2, 3,
Yeah.
and it's got one double bond right here. So we call it propene. And let's say you got lots of propene. Not just this one, but two of them. See?
Okay.
Then this one. Then this one. And then this one. See? You got lots of propene. Yeah. So under the condition of high pressure and temperature, and sometimes some catalysts, this propene, their double bond will be broken.
Okay.
Yeah. And they turn to this. Give me a moment.
So I know they turn into single bond.
Yeah, that's correct.
How do you draw like?
Right here, I'm showing you how they form. So the double bond breaks, and there are 3 bonds for the 2 carbon. Okay?
Okay.
Yeah. And what happens next? Then the carbon with a 3 bond right here will connect to the carbon with a 3 bond right here, and to make a very long chain of polymer. See, it is very long. It
Okay.
keep becoming longer, non-stop. There. Yeah, they connect. See? That's how it works. So yeah, so from like the molecules here, you just form a long chain of polymer. Yeah, and the monomer of the polymer here is propene. Understood? We call this monomer. The monomer of this one is propene. Yeah, so this is one propene, and this is called polypropene.
So all of the carbon double bonds will be broken to single bond.
Yeah. And when once they're broken, the molecules can bond together to make a long chain.
So like, what happens if there's like bonds this way, like, and there's maybe alcohols are used, but I don't know, I saw some questions like we have to draw, so like you have to draw, and there's like another double bond here, and it goes down, so all of the double bonds will be into single bond.
Yeah.
In this case, if there's more than one double bond.
Or if there is more than one double bond,
Yeah.
wow.
I mean,
If there is more than one double bond, then we don't know which one will be broken, or whether they both break.
okay, so there's only just one.
Yeah, because as in your syllabus, you only learn about alkene, and alkene has only one double bond, one CC double bond.
Okay, that's it.
Yeah. Okay, so the difference here again you can see is that addition polymerization doesn't produce small products.
So it doesn't produce water in addition.
Yeah, correct. Yeah, but actually, water is not the only side product that can be produced in condensation polymerization. But there are some different types of side product like water. But in your syllabus, you only learn about this case, the water one.
Okay.
Yeah. Okay, and that's all. That's the difference between them. And one more thing is that addition polymerization requires CC double bond.
Well, condensation do not right? They don't.
Yeah, the condensation one doesn't require CC double bond, but instead they require the two functional groups be able to form water.
Yeah.
Yeah, so for Na2 it requires one H, and for the carboxylic acid it requires an OH.
OH.
Yeah, so if two functional groups they are able to make a water, then they can be connected by condensation polymerization. Yeah, that's how they're different. Okay, that's all. Anything else about these?
No, but I have something else I'm very confused with. Like I saw a lot of questions about. It's like the light ray, and you have to sketch the diagram where the image is. Like sometimes it's behind the, and like sometimes it's another place. So I'm very confused with how to draw it.
So you want to know how you draw an image of an object, right? Before a mirror, produced by a mirror, right? Yes, of course. But I'll show you the principle first.
Yeah, sure.
So one it got a mirror right here. Okay, it is not here mirror, and this mirror, and you have a point A. See? Yeah. And the image produced by the mirror of point A is this one. The principle here is that the distance from the object and the image to the mirror, they are equal.
Like the same.
Yeah, they are equal. See? Yeah. And the segment connecting the two object and image, they must perpendicular to the mirror. Yeah. That's how you draw the image produced by a mirror. That's the
Okay.
principle. Or sometimes they give you 2 points.
Yeah.
So it's just they give you a segment like this, see? And they want you to draw the image of this segment.
Usually the point will be like down here or something.
No, just this segment right here.
Okay.
Okay, so you already have the image of A, then you just need to draw the image of B. See? Also perpendicular, equidistant, and connected two images. See? And A, what do you call this one?
This one?
Yeah, the one here.
Take an enlarged version.
No, I mean the how you say it. How you say it.
It says the big. I don't know. But
Yeah. Just the thing is, so the image of the segment AB is this one. See? You have to draw the image of a triangle like this. See? A triangle ABC.
okay.
So you just need to draw the image of C. See? Same distance, perpendicular, And then you connect the images together to have the image of the whole triangle. And that's the principle.
Okay.
Okay, so this is what we call the image produced by a mirror. Uh-huh. Okay, is that the question? Or anything
Well, I
else?
mean like usually there'll be like a mirror here, another point that's like somewhere here, and you have to draw like a virtual image of it, and like you label the image. I think maybe.
Oh,
like that.
so it's not mirror, it's lens,
Oh, lens. Okay.
right? You mean a converging lens, right?
Oh yeah.
Oh, here. So it's not mirror, it's the image produced by a lens, lens. Okay, so so you got this one. What is the name? Just forget it. And then you got lens,
Yeah, that one.
converging one. See, it is the symbol for lens, converging lens. Okay.
Okay.
And for lens, you got 2 points, 2 focus, 2 foci,
So that one.
One here.
and-
and 1 here. And you got the optical center right here. And don't forget that these 2 F's are equally far from O. Okay, and then you got this one right here. It's just an object with the direction upward. See? And then you want to draw the image produced by this object
Yeah.
through the lens, right? Is that what you want?
Yeah.
Okay. So this is how we do. First, you draw a line from the top that is perpendicular to the axis here.
Okay.
See?
From the top. Okay, and then.
Yeah. If the line right is parallel to the axis, then it will be bent, so it can pass through the focus on the other side. Understood?
Okay.
Not every line ray has this characteristic. Only the line ray that parallel to the axis, the horizontal axis here.
So you draw that one.
Understood? Okay. And the other line must pass through the optical center.
So also from the top.
Yeah, also for the top. Because we're drawing the image of the top.
Okay. So through. Yeah. Okay.
They're not gonna meet, so I'm gonna just make it somewhere here. Or I can just bring these. Give me a moment. Okay. Yeah, so they meet here. See? You see it?
So,
they meet right
okay.
here.
So what happened?
When you encounter this question, they will give you enough space for the diagram. Yeah, so you don't have to worry if you don't have enough space. Here, it's gonna be like this, right? Yeah, because the image of this point right here, it must be this point.
So this is the virtual image.
Yeah, this is visual image.
Okay.
And it is also inverted one. Upside down inverted.
Yeah.
Okay. Yeah, so to draw the image produced by lens, you have to draw the image produced the top of the object. Yeah, so normally they will give you a standing up one. So you just draw the image of the top of the object, and then you make a perpendicular segment for the whole image. That's all. Is that your question?
Yeah, and then another case, the image would be behind this arrow. So
Mm-hmm.
how it's another way you can draw it.
Okay, so here. So let's take this thing. Okay, so we have this one. Okay, so if I wait, give me a moment. Oh, why don't I just do it like this? I put it here. See? Inside the OM. Between O and M. So the distance of the object to length is smaller than the foresaw length. See that? Okay. You also draw the image of the top. What is the first line?
It goes through the
The origin? Or
origin.
the optical center, right?
Yeah.
Okay. What is the other one?
It's like a straight line to the middle, then to the
It must be a
yeah,
parallel line.
yeah,
A
like that.
horizontal one. See? Yeah. Horizontal one. And if this one is horizontal, then it will bend and pass through the other
The
focus.
focal point.
See? Here. Way. Here. Okay. And as you can see, they are two diverging rays, which means they cannot
Yeah. Form a virtual image.
Yeah, that's correct. They cannot meet. So there is no virtual image here. So how do we draw the image of the product here?
So you have to draw.
We have to
Straight.
lengthen the line so they will meet at the back of the object.
So what do you call that point? Like, is the image, but what kind of?
It's also the image of the top. See?
So it's also called image.
Yeah, it is the image. What do we call it?
What's the name?
Give me the name for this type of image, right?
Yeah.
Is it an imaginary one?
Well, I don't know.
Wait, give me a moment. I just forgot it. Oh my god. Virtual versus wait, let me ask my wait. Oh my god, just forget it. Oh, my bad. Sorry. Here. This image, you call it the real image,
Okay.
not the virtual one. This one called real image because it can be projected on the screen. Yeah, like if you put a screen right here before the object, then you can see this image projected on it. Okay? But if you use a screen behind this, you cannot see the image. Okay, so we call this type of image virtual one. Yeah, this is called virtual.
Okay.
Virtual image. Yeah, and for virtual image, you don't draw a full fill line, but instead a dashed one. And remember that, a dashed one like this. Why so big? Yeah, I have to make it smaller. Yeah, a dashed one. See, and also the lengthened part. The lengthened part of the two rays, they must be in dashed line because they're not real.
Okay.
Yeah, we cannot see it. If we put a screen after behind the lens here, then there will be no image at all. You cannot see the virtual image if you look on the screen, but you can see the real image here. And it's called real image. If you put a screen here. Yeah, okay, try
So I'll
it.
just
Difficult.
put my, I don't want to hold. Is that? Yeah, I think you can still see it. Okay. Alright.
Okay. And yeah, understood. And what is the condition for you to get whether you get the real one and the virtual one? Is the distance of the object to the lens. See? If the distance of the object to the lens is smaller than the focal length, then the image will be virtual. See?
Okay.
Understood? The image here, the distance of it to the lens is smaller than the focal length. So the lens produces
No,
a
but what's
virtual
smaller?
image.
So this
one right here. Here, the distance here. See?
So if this is smaller than the distance here, then the image will be from
Virtual.
yeah, virtual.
And if the distance is larger, see?
Yeah.
If the distance is larger than the focal length, then the image would be real. Yeah, and for a real image, it is upside down inverted. And but for the virtual, it is the same direction as the object.
So upright.
Yeah, upright. Okay, that's all, and that's are the conditions. What else? What else do you want to ask?
Maybe. What's the contact process?
The contact process. Oh, you mean the production of sulfuric acid, right?
Yeah, no.
The-
Yeah.
Yeah, there's two processes: the contact one
Like
and the Haber one.
I want to know the conditions and because those questions they always come up.
Okay.
Yeah.
So here, there are two types of the processes here: the Haber one and the contact one. So we call it processing, and this is process two. Okay. So here, about the, but you already know the Haber, right?
I know the conditions for Hamburg.
Okay, you're just talking about condition then. For harbor, it's gonna be 450 degrees Celsius. And for contact, it's also,
So they're both 450.
that's correct.
Okay.
So they're the same temperature. For pressure,
200
200
atmospheres.
atmosphere.
Is it? It's two.
2,
atmosphere?
that's correct. Only 2.
Okay.
Yeah, so this is the difference. This happens at high temperature, at high pressure. But this one, only small pressure, low pressure.
So
Okay.
what's so the catalyst? What is it? Iron catalyst for Harbor process?
Yeah, and catalyst here.
Okay.
For
And
this one is,
vanadium oxide.
that's correct, vanadium 5 oxide.
Yeah.
Okay, but here's the different one. The process here has only one reaction, which is nitrogen react with hydrogen.
To make ammonia.
Yeah, to make ammonia.
So NH4.
See?
Or NH3.
Yeah, so this one is 2 and this one is 3. And iron is the catalyst for this reaction.
So does this mean like they are reversible?
Yeah, they are
Oops.
reversible. This one is reversible.
Okay.
Okay, but this one, first, you have to burn sulfur to make SO2, and then
Yeah.
SO2 will react with oxygen in a reversible reaction,
So 2 SO3.
and those 3. Actually, if you wanted 2 here, then it's gonna be 2 here, and then
Yeah.
3 here. Is it? No, it's 2. Oh wait, what? Yeah.
Yeah.
And vanadium dioxide is the catalyst for this reaction. See, so we need the heat here. When you burn the sulfur, you need heat.
So that's the temperature 450. The heat.
All the things.
Okay.
Okay. You mean the 450 here?
Yeah. So
No,
the
no,
heat-
no, not. It's not the heat. It's for this one.
Okay.
Also the pressure for this one only. See? Yeah. And then SO3. So SO3 can react with water to make
H2SO4.
H2SO4. But this reaction is very toxic.
Okay.
It has
so-
lots of gases, the toxic gases. So in industry, you don't use reaction to make sulfuric acid, but instead they will. Sorry, give me a moment. Let SO3 react with a solution of sulfuric acid.
Yeah. So and then it will become H2S.
H2O Seven.
O7.
which is also called oleum. See, oleum.
Oleum. Okay.
Yeah.
Need to charge.
Okay.
Yeah, I need to charge my phone. It's dying. Okay, continue. Ooh. Yeah. Okay.
Okay.
So
And then the oleum react with water to
So-
make sulfuric acid. But the amount of sulfuric acid here is higher than here. Understood?
yeah.
Yeah. And those are the four equated reactions for the contact process. So remember, the condition of temperature, pressure, and the catalyst here is they are only for the reversible reaction here. Okay.
So okay, there's okay harbor contact and then there's one. What's like? Oh yeah. What about? Which one else? Okay. Oh, can you tell me about the cracking?
The cracking?
Yeah.
Sure. Cracking of alkanes. Okay, so one alkane is cracked, they become alkene, and
Smaller alkaline.
yeah, a smaller alkene. Or this can be hydrogen and alkene.
What about? Oh, wait. Okay. Yeah.
Okay, so let's take some example. Now you got C34 3470. This can be cracked to C2 4 and C32 H 66, right? So this one is the smaller alkene, and this one is the
alkene.
alkene. But this alkene can also be cracked. Yeah. So let's take another example. It can also be cracked to C10 820 and C 22 846, right? So here's another alkene and an alkane. It also can be cracked, continue cracked to hydrogen and this one.
Okay. So this process is like continuous until all of the small alkenes use.
No,
Or
that we don't know if we don't know the conditions. Yeah, the cracking here they must be set in high temperature with catalyst. Yeah, so depending on the reactant and the condition,
okay.
then you have a specific product. Yeah, so we don't know which product it is until we know the condition here. But in your syllabus, you also don't need to know the condition. Yeah, like you don't have to show that what the products are, but you just know the principle here. There's also alkene and
So
alkene.
what are the conditions for cracking? So, like I remember it's like a catalyst for this. So in the question, it only requires the answer to be catalyst.
Uh-huh. You don't have to know what
Oh.
catalyst it is. You just need to know that it needs catalysts and high temperature.
So you also don't need to know the high temperature or the amount of pressure.
No,
So-
only Haber and contact process.
Or has pressure.
Yeah,
Okay.
this one is for high pressure, high temperature and catalyst. Okay. Does it mean that?
So only conditions are catalyst and high temperature.
Yeah,
Okay.
high temperature. Okay, what else?
Uh, hmm. Well, I don't know what question. Like, okay, I'll look through.
Sure. Let's take a look.
Right. Here, like these questions here.
This one? C? Which is C, right? Is it?
Yeah, this one's C. Like I don't know the for the concentration is difficult.
The student makes up a solution of dilute sulfuric acid with a concentration of 0.2 mole per cubic decimeter. Calculate the concentration of a solution in gram per cubic decimeter. Okay, you're finding concentration, but they are in different units, right?
Yeah.
Yeah, they give you the concentration of a unit of mole per cubic decimeter. But they want you to find a concentration in the unit of gram per as a per cubic decimeter, right?
Yeah.
So what is different here? You have to convert from mole to gram. But what is the quantity for the unit gram? What is quantity?
Quantity.
Yeah, what is quantity that has a unit of gram? You got mole per cubic decimeter. You have to convert it to gram per cubic decimeter. Yeah. So what is the quality that has the unit of gram? Is it a mass?
Mass? Yeah, I think. Yeah.
It is,
So mass.
yeah. So that means you just need to convert the number of mole
Oh,
to the mass.
so concentration is just the mass.
No, I mean for in this case,
Oh.
you're finding the mass of the mole given here. So 0.2 mole. 0.2 mole is equivalent to 19.69 gram. Understood? When you convert mole to gram, that means you have to calculate the mass of the given mole.
Oh, okay.
But it's just 6, not 9 here. It's just 6 here. Okay. And that's all. When you convert mole to gram, that means you have to calculate the mass of the number given mole. The given number of mole.
Okay.
What else?
9.
Want to continue reading?
Oh, okay. Oh, my phone's gonna run out. Mm.
Yeah. Just
Okay. Oh yeah. So okay, so if you join like this question here, like so the double bond here like will just be broken, right? So the rest you keep the same.
yeah, that's correct. Only the two carbon with the double bond has three bond.
So you keep this like
Keep everything the same.
Okay. Oh yeah.
What else?
I need to go charge my phone. Like, can you help record?
Oh, is it still recording?
Okay. Can you send me the recording link? You have to go charge it. Okay. Alright, so I'm feeling trouble. You should have to know about the okay. Like I'm thinking of what else.
Yeah. Maybe because you have revised a lot, so you don't have any questions.
Oh yeah, the Mulder questions about that. Like, what? Like how does something induce current? how induced EMF, like those questions.
Oh, you mean the induced EMF? I gotta find a cap. Okay, so induced EMF here. Let me show you. Induced EMF. Yeah, give me a moment. Oh wait. What is it? Wait, give me a moment. It is here. It's gonna be what I do. Give me a moment. I don't know where it is. Oh, it's not here. Or maybe I just it says here. Oh, I forgot. Induce EMF here. Huh.
Circular coil out of copper wire.
Okay, so you
Connect the
have, just shut up. Okay, you got wires. See, you got some wires here, and then if you and there's an ammeter to measure, to galvanometer to detect the current inside the wire. See, so as you can see now, there's no current in the wire. The galvanometer 0.0. See? Understood this? Yeah. The galvanometer 0.0 because there's no current passing through the wire. Okay, next. If I put a magnet in here, let's see it again. Okay, here. This is a magnet. What is the thing that's surrounding a magnet?
The magnetic field.
That's correct. So surrounding magnet is magnetic field. And when we get closer to the magnet, the strength of magnetic field increases. Right? Yeah. So see, when they take the magnet away from the wire, then the magnetic field passing through the wire changes. Right? When they take the magnet far away from the wire, then the magnetic field also decrease, and this decrease of magnetic field produce an induced current inside the wire. You see that? Yeah. So here, what if they make the magnet closer to the wire? See? Yeah.
So the current, like, it goes
Up here again.
like right in here.
Yeah.
So it makes the voltmeter turn. Yeah.
Yeah. And that's what we call induced current or induced EMF.
So like a magnetic field experience.
When there is a change in the magnetic field passing through a wire.
So a question is like how an EMF is induced. So the magnetic field is changed. So that's the first thing. And what is it? What's next? It's like experience. Like cuts.
Touch.
No, cuts.
What is the question again?
Like how like something about induced EMF. Like how does it happen?
Yeah. Like I said, if there is a change in the magnetic field passing through a wire, then there will be an induced EMF inside the wire. Yeah. Induced EMF only occurs or only exists in a wire when there's a change in the magnetic field passing through it.
So the current cuts the magnetic flux.
No, the magnetic field passes through the wire.
So what cuts the magnetic field?
What?
Usually?
What cut the magnetic field?
Yeah.
What do you mean by cutting?
Like sometimes I see like when I check in the marking scheme, it says something cut like a magnetic charger. I don't know.
The wire? Yeah. If there's something cut, then that's the wire. The wire cuts the magnetic field.
So wire cuts the magnetic flux, and like this induces EMF. Okay.
But that's not a condition. If the wire just cut through the magnetic field, there will be no induced EMF. But if you take the magnet away, then the magnetic field will be changed and there will be an induced EMF. Yes, so the key word here is the change of the magnetic field. You can use the word cut, but for more specific, you have to use the word change. Yeah, if there is no change in the magnetic field passing through the wire, so there will be no induced EMF. Okay, that means to produce the induced EMF, the magnets have to be
Cut.
have to be put away and pushed close to the wire in turns. See, you have to keep make it happen. Yeah, that's
Okay.
how it works.
So, yeah. So what? I have one more thing I'm very confused about.
What is it?
So it's like the electrolysis one, but in aqueous. So usually there's like hydrogen and oxygen is there. So how do I know when hydrogen or oxygen will be formed instead of the other reactants?
Okay.
Yes.
So about electrolysis. If the anion SO, like SO4 2 minus or NO3 minus, then
So it will be formed at the atom.
yeah, water will be water will be oxidized
So,
in the
wait,
anode.
so oxygen will be the product made at the anode.
Yeah, that's correct.
But I know that. So what about hydrogen? Like that's what I'm confused about. Because sometimes like and hydrogen can be formed, but other cases the other like negative electron can be formed there. So
Yeah. So here's the thing. Let's take an example here. Example 1, you got
chlorine.
sodium chloride. Okay? Oh no, just Cl2, copper 2 chloride.
Yeah.
Yeah? First, when you put it into water, they will dissociate into Cu2 plus and Cl minus, right? See? At the anode, when you put this into water, when you dissolve this into water, they will form the ion of copper and the chloride ion. Yeah. And also, there are water in the solution, right? Yeah. But anode, the ion that comes to anode is the Cl minus. It comes to anode to produce Cl2 and lose 2 electrons. How about the cathode? Cu2 plus receive 2 electrons and become pure copper. You know
Yeah,
this, right? Okay, another one. Let's say you have CuSO4, copper 2 sulfate. Here. Dissociate into CO2 plus and SO4 2 minus,
And
right?
H plus OH minus.
There's always water in the solution.
Yeah.
Yeah. So at the anode, SO4 2 minus cannot be oxidized
Oh, but why?
because it's cut O. Every anion with O cannot be oxidized by the anode.
I thought you said anything with O will go to the anode.
Will not go to the anode.
Oh.
Understood? Anode is the positive electrode, so the anion will come to it. But in the case of aqueous electrolysis, the anion that comes to the anode is not SO4 2 minus, but the OH minus of water.
Oh. Yeah. So, okay.
Okay? It becomes O2 8 plus.
So when there's an O
Mm-hmm.
and okay, so then the oxygen will be formed.
Yeah.
Alright, so
If
okay.
there's an ion having O, the oxygen will be formed. How about cathode now? It's Cu2 plus, right? So it's
So I
Cu2
don't
plus.
know when hydrogen will be formed. Like how do we decide like
Here.
okay.
And this example is for the hydrogen one. You got NaCl dissociate into Na plus and Cl minus. What happened at the anode? Cl minus doesn't have O, so it
So,
comes to
yeah.
the anode.
So Cl.
See?
Okay.
And how about cathode? In this case, you got sodium ion. Sodium ion cannot be reduced at the cathode electrode. Here.
But how do we decide like why?
So hydrogen will be reduced to
Yeah.
hydrogen. And we decide it based on the reactivity of the metal. Sodium is a very reactive metal. It is way reactive than hydrogen. Yeah. So the H plus ion will be reduced first
Okay.
to hydrogen.
So I have to remember the whole reactivity series.
No. Only copper and silver. If the cation is the ion of copper or silver.
Oh, so that's it. So
That's it.
anything else will
Produce hydrogen.
okay. So silver, copper.
Only silver and copper.
Yeah. Yeah, I think that's
Okay. So let me ask you some random question. That my other students, they sometimes they make mistake on them. Okay, so here it's also about electrolysis. If the positive electrode, which is the anode, is made of copper 2 sulfate. Oh, sorry,
C.
copper. Not it's only copper.
C
If the anode,
plus.
or you can say that if the two electrodes are made of copper, and the solution of the electrolyte is also copper 2 sulfate.
Okay.
Okay. Is there any change of the color of the electrolyte solution during electrolysis?
So just copper is used in the
Anode. Copper is used at the anode, and the solution of electrolyte is
Yeah.
copper 2 sulfate. During electrolysis, is there any change? And what change it is? Of the color of the solution.
so copper will still go to the cathode.
Yeah, the copper 2 plus still go to the cathode.
So well usually is there color change in electrolysis?
Is it?
Right.
The color of copper 2 sulfate is blue,
Blue.
as you already know. Yeah. So is there any change of the color during electrolysis while using copper as the anode?
So there's inner.
Just yes or no?
So there's no change.
Yeah. So why is it no? Why there's no change?
Because it's just copper that reacts with, so that goes to the anode. There's no other. Wait.
If the copper ion go to the cathode, it will turn into
Copper.
copper.
So pure copper. Is
Yeah, pure
blue
copper. Pure copper is red,
or red.
but it's not dissolved in the solution anymore. Yeah, it stay at the cathode. The color of the solution is from the Cu2 plus. Where Cu2 plus turn to copper at the cathode, then the color will be
Blue.
pale. Here, let me show you. You got two electrodes. One of them is made of copper. See, it is the anode, and one of them we can make by anything. It can be also copper, but just say it graphite. And the solution here is the CuS4 solution. That is the
Oh.
cathode, this is anode, right? So, at the cathode, the Cu2 plus will be reduced to Cu. See? So there will be less Cu2 plus in the solution. The blue color start to disappear. Understand?
Oh, okay.
Yeah. But at the anode, the copper here will be oxidized to copper 2 plus and lose 2 electrons. So the copper electron here will dissolve to the solution and compensate the loss of Cu2 plus. So there will be no change in the color of the solution.
So no change.
Yeah, but what if I use another electrode made of graphite? Will the color change?
Yes, because
That's correct.
so the copper is gone. So
And there's no compensation, right?
yeah.
So the color disappear and the solution become colorless. Understood?
Yeah.
So you have to understand the process at the cathode and anode, and you have to choose correct ions that will come to the electron.
Alright.
That's all? Anything about biology? Can you name the planets in the solar system in order
Okay.
from the sun to the furthest?
So Mercury,
Mercury, close to the sun.
Venus,
Venus,
Mars,
where's
Earth,
Earth?
or Earth, and then Mars.
Earth, Mars,
Jupiter,
Jupiter,
Saturn,
Saturn,
Uranus, and Neptune.
Neptune. Is there Pluto?
No.
Yeah, Pluto is not a planet in the solar system anymore. Okay, that's good. That's all. Yeah, that's something that I think. And but I think you should learn the formation of star.
So like protostar, right?
Yeah, two different kind of star.
Yeah.
Star.
I remember it's like the gravitational
Force.
force. Like it makes the interstellar clouds of dust and gas
Mm-hmm.
form at a tiny point. So and then it creates a protostar.
Yeah.
Yeah, that's it.
But for protostar to
Oh, okay. And then the protostar begins to expand and becomes a red giant
yeah,
or red supergiant.
yeah. What else?
So, like in the red giant, so the process of thermonuclear fission happened.
Mm-hmm.
So it's like the inside that has hydrogen and helium. Yeah. And so as the fuel runs out, like the red giant or supergiant collapse on itself and it forms a planetary nebula and white dwarf.
Mm-hmm.
And if it's a red supergiant, it will form a black hole and supernova.
Okay. Then you should read it again.
Yeah, is it like the new thing is just added?
Yeah. And there's a formula to calculate the period.
So it's 2 power T.
Yeah, correct. Where is it?
The last one,
The last one.
last chapter.
Okay. Yeah, it's a new one.
Oh,
So you have to learn the process of each one carefully.
yeah.
Yeah, because you don't have any chance to practice it before, right? Yeah, so they may ask you about the two processes here. The red giant and the red super giant.
Okay.
Okay? Planetary nebula, white dwarf. And you missed one case of the supernova. It's
Or neutron star.
Yeah. So a supernova can become a black hole or a neutron star. And that's all. Good. Okay. If you don't have any more questions, then you can end here.
I don't think.